So my question is how we will auto scale Kubernetes pods. Okay, any idea?
In our deployment script, we replica.
In deployment script,
Yeah, the deployment at the amplifier, you can specify the replica.
I mean, coming to Kubernetes, there is a resources. You know the term or the name to fulfill this. I mean, auto scaling. For example, this is our desired state. Okay, to running an application, our replica set is equal to 2.
So
So
are you saying auto scale replicas based on load based on need?
your voice is not clear actually.
Are you talking about scaling or auto scaling?
Scaling, not no
Okay.
auto scaling. Because coming to production environment, there is multiple containers like 100 or 2000 or I mean 200 or 500 containers there. So we can't scale, I mean manually scale each of them. That's why we are using Kubernetes, right? Container orchestration. So the Kubernetes will automatically scale the resources. One of the feature is auto scaling. So what will happen using auto scaling? Scaling the resources. Got it? Yeah. The name in Kubernetes, I mean the resource name is HPA, horizontal pod scaling. Sorry, horizontal auto scale, horizontal pod auto scaling, horizontal pod auto scaler. This is a resource. Okay. So using this resource, we can automatically scale up our running pods. I mean, coming to Kubernetes cluster, this is a crucial resource that will automatically scaling the number of pods in a deployment. Not in the deployment replica set or stateful set, based on based on what? Based on the requirement. Okay, for example, it will observe the CPU utilization or other metrics like memory utilization. We can set as per our requirement. Uh, Let me show one use case. Okay, I mean, there's a web application in Kubernetes, and the traffic to our application can vary throughout the day, right? For example, these are the running desired state. Okay, there is two pod, I mean two replica, and we expose this inside two prompt there is two application. Okay, I mean the single application and we clone up with the two. So sometimes I mean the morning time or yeah morning time the traffic is low. Consider it's medium size. Then coming to I mean low traffic. Okay, considering the daytime, but afternoon it will like I mean there could be a spike. Okay, significantly spike there. So we can use for that scenario we can use horizontal code autoscaler, right?
So does Kubernetes has its own metrics, or do we need to install any metrics tool?
Yep, right. We need to install the metrics before configuring HBA. There is a API metrics there. I will show you in the lab how to configure, I mean, how to install the metrics. Because we are calculating based on the metrics, right? Otherwise, how can we calculate? I mean, the HBA couldn't calculate the thing. I mean, the UPA, CPU relation or memory utilization. I'm quickly create a pod, okay? Sorry, a Kubernetes cluster. Okay. So I will share me the previous section, right? I mean the Kubernetes 10-tier microservice application. Uh, did you go through this? I mean, this is our manifest file, okay? So coming to source, you can see the split up of our YAML file, okay? I think that's in Kubernetes manifest, okay? See, these are the single manifest for each services. Got it? And coming to release, you can see all the YAML in a single manifest. Mm. So coming to Autoscaler, okay. This is the YAML for auto scaling. I mean, for horizontal auto scaling, we need to deploy one resource. That the resource name is horizontal pod autoscaler. My screen is visible, right? So this is the API version. This specifies the API version of the horizontal pod autoscaler resources, and it tells with the Kubernetes API version interpret these resources. So that this is a kind. Okay, kind is our, in this case it indicates horizontal autoscaler resources. Then metadata, under metadata, this metadata is for HBA. Okay, in this case, our name is horizontal HBA demo deployment. This, see, this is our name. Okay, then coming to spec scalar target reference. This is a section contains a specification of this HBA. So see, scalar target reference. This part specify which workloads, okay, which workloads the HBA should target for autoscaling. In this case, the target is deployment with the name. So the kind is deployment and the name is HBA demo deployment. And app, yeah, see, the API version is API app v1. That's API version. And this reference means that the HBA will automatically adjust the number of pods in the HBA demo deployment. HBA demo deployment. Based on the HBA demo deployment, whenever the target, I mean, this utilization is, I mean, this is triggered, okay, above 50%, then this autoscaler will running. I mean, inside the HBA, we specify we need a minimum replica is 1. So it ensures that there is one pod is running healthy. And after 50% utilization inside the pod, CPU utilization, then this will working. Okay. I mean, it's go to up to 10 pod. Okay. Here, see, maximum replica is 10. And the minimum is here 1. So these are the things maintained by the HPA. Okay. One of the other thing in the Kubernetes manifest, I mean Kubernetes cluster is called. Anyone know how we keep the secrets in Kubernetes? For example, we have one database. Okay, there is a Mongo database. We are running that database, and we need to integrate that database with some other microservice application. So we need to provide the database username and the password, right? So how that will pass and how we keep the environment variables.
Secrets?
Yes, secrets. I mean, as secrets.yamls. So we create a special, I mean, specific YAML file for keeping the secrets. And inside the secrets, we provide the username, password, all the things. For example, this is not for a username and password. Sometimes we need to pass the APIs. Okay, so we need to keep the APIs there. then certificates, okay, SSL certificates there. So like that, we what are the secrets in our inside our resources? We keep all the secrets in the secrets.yaml. See, this is one of the secret I will show Mongo. This is a deployment for the MongoDB, and this is service for the MongoDB, and this is a secret. So for that, we keep like this, okay, for MongoDB database. So this is a version and kind. There's a kind for secret, okay. So we need to mention kind is secret. So the Kubernetes know this is a secret. And the metadata, then this is a namespace where the application belongs. Here, this is a workshop namespace. So there is a namespace in the Kubernetes cluster called workspace. Then this name of the uh, deployment like Mango secret. And the type is opaque. Okay. You know what is opaque? It's not visible. I mean, coming to the cluster environment. Then the data under data, we provide the password and the username. So this is the username. The username like this. Okay. This is encrypted. Okay. See, actually this is admin, but this is encoded with some encode. I mean, there's a hash. Okay. And this is password 123. So the password 123 is coming to this. We can decode this both. Okay. So after we decode, we can see the password is password 123, and this is admin.
So this is the secret file.
Yeah, this is secret
Hello?
file, secret.yaml.
So whenever we want to launch Kubernetes cluster, are we gonna create this secret file different from the service and then the
Yes,
YAML
yes,
file
yes, yes,
itself?
yes, yes. See, this is another kind, okay, like deployment service. So this is another client, like secret. And coming to same for the HPA, also known sports scaling, this is another type of kinds. I mean, these are different resources inside Kubernetes.
Okay.
So now we are going to deploy a sample application, or I mean, that's a, I mean, for the, we're testing the HPA, okay, how the HPA will work. So that we need one Kubernetes cluster, and we need a Kubernetes cluster. There is sample application running app there with one or two port, okay, with one or two port. Then these are the prerequisites and ensure that the metrics there. Okay, I mean, given metrics is we install the API metrics, API metrics. Then we deploy the HPA resources. Then we need to test the thing, right? I mean, the CPU utilization, we need to manually load the CPU utilization above 50%. Manually or test load, okay. Yeah, my cluster is almost running, I think. Stack down group. Because coming to production environment, there is a lot of containers. So that's why we are using Kubernetes for auto scaling these types of auto. I mean, whenever the CPU utilization is high or memory utilization is high, we need to scale up our resources. And after the utilization, it will come back to the desired state. We didn't bother about anything. Otherwise, we need to go to each containers, okay, as per the requirement. I mean, each container utilize more resources, then we just go there and spin up the thing, I mean, manually. Just how we manually scale the resources, I mean, the pod. The manual way. Anyone?
Are you asking manual way or auto way?
And manual way.
Manual way, we need to modify the deployment YAML.
Right.
But here
Just open the YAML file and change the replica set as our deserves. I mean, our requirement. For example, it's running into pod, and we just change as 4 or 5. Then we need to ensure we need to scale out the thing, right? Also, sometimes the traffic will go down, right? So we again go to the YAML file and change it as to the desired state of 1 or 2, like that. Just assume if the container size is above 100 or 500 or 1000, what will we do for the scaling? It's a tedious task, right? So that all things will done by Kubernetes. That's why we call the Kubernetes is a containerization organization tool, and it will automatically deploy, scale, auto scale, monitoring, all the things, right? Yep, cluster is ready. See, my cluster is ready, and with 3 node, I'm creating a directory. Test HPA. CD test HPA. Okay, ls. Okay. So now I configure this cluster, then I need to deploy a application. So we're going with the sample deployment. Okay. Just I will clone up the thing, that's better. I'm going to the directory. Here our app code belongs. Okay, you can go to the corresponding. Yes, everything is here. So I'm going to deploy the deployment YAML and the service YAML. What is in the deployment YAML? Check. Okay. So this is a sample image. Okay, see KGCR sample image. I mean, it will create a, I mean, two pod. Okay, sorry, one pod. So I'm going to deploy kubectl, apply file name, kubectl, apply file name. In a single apply, I mean, kubectl apply, we can specify our required files. Okay, just mention the file name space the file name. In our case, there is two file name. Then we can add one more file. Okay, I mean, there is one more file there. Then we can specify the file name. Now both are created. Okay. So see, the deployment name is HP deployment. Okay. And deployment apps, HP deployment. This is service and this is a pod running. And the replica is one. Now I need to install. I need to install the API metrics. So before that, I will show you why we need to install API metrics because we couldn't see the running pods metrics or nodes metrics. Okay, like kubectl top node. See, metrics API is not available. So we need to manually install the metrics API. You can directly, there is applic YAML file there. You can apply it directly. So I'm using kubectl apply. Then the file name. Okay, here we can specify the file name as a URL. HTTPS GitHub. The file is in the GitHub. Okay, github.com/Kubernetes. Kubernetes sign text. server releases, let us download components for YAML. Hit enter. See, kubectl get deployment matrix. This is, I mean, when I hitting the command kubectl apply the URL, it will create a deployment called metrics server. Metrics server. And this will running in a default namespace. Okay. So the default namespace means cube system. Cube system. See, our metric server is up and running. Now we can try the kubectl top node. Okay. kubectl top node. So it will shows the CPU memory utilization and all the things. See, each pod utilize. I mean, the first node utilize 1% of CPU, second is 2%, and the third one utilize 1% utilization. Same way we can see the memory utilization, memories and the memory utilization. We can check the pod as well, okay? Pod. 1M and 8. Get pod. Yeah. This specific application running in this machine, I mean the pod is 50. That's why its utilization is 2%. Okay. So now we are done. I mean, install the API metrics. Okay. So the next thing is we need to install the HPA. So I'm going to apply. See, horizontal port scaler dot auto scaling. Then HPA demo deployment is created. So we can see using the kubectl get HPA. Okay, kubectl get HPA. Sorry. See, this is the deployment of the HPA, and this is a reference. See here we can see the target. Okay, in our case in the YAML we specified the I mean I'll show you utilization is equal to 50. Okay, see target CPU. This matrix is for utilizing. I mean we are using for checking the CPU utilization. Okay, so here we mentioned the CPU target CPU utilization percentage is 50. So here we can see the target is 50. And this is 0 because our ports doesn't utilize more. Okay. Now only not 2% there. And here we specify the maximum CPU. I mean, the port count is 10. I will change as 20. Okay. Again, apply. See something configured. That's why it's seeing this configured instead of create. Before we see the created, now it's configured because I edited the thing. So the given no. Now the maximum one count is 20. Okay. So now we are good to go. Then we need to test this will work or not. So there is a application like busy box. We can utilize that application that will load our pod. Okay. So yeah, meantime, I will create one more partial window to see. Okay, fine. Now I am going back to the my previous. I'm just open one more window. Okay, that's all. So this is the command. Okay, to I mean this is for the loading. Manually we loading. I mean testing the CPU of the pod, and this command will be execute when this executing and the CPU utilization is going up. Hit enter. See, this is testing now. I'm just to go back to the previous, I mean, another windows to see. Wait. Now the target is 0. Okay, it will take some time. See, the percentage 166%. Okay. We'll check kubectl get pod. See, our pod is no. Before there is single pod. Okay, now it's going to 6 or 5 or 6. Again, you can see it's counting. See, container creating. It's 161. As of now, we have 5 replicas. Pod. See, there is 7 containers created. Okay. And now it's going down. That's why it's not creating another containers. See, the percentage coming back to 65 percentage. So it will delete. We can see that thing. See the utilization. These are the utilization inside the memory. I mean the each port. Will take some time to cool down. I mean, going back to the previous state. Okay, our state, like our previous state is 7. Okay, desired state. In this, I mean, desired state is 1. It's cooling down. Okay, see, 43. Before is 46. Now I am going to break this command. Okay, now it's break. So here you can see that generator is turned off. Okay, CPU is cooling. Yeah. I mean, still the ports are running. Okay. I mean, after the load, I mean, this will come back to the desired state. Okay. See, we already mentioned here one and max or changes back as 5 or anything like that. Okay. Like 5. Then I will turn again. Yeah, now it's cooling down, right? See, right. Now it's done. I'm doing anything, okay? Just change the thing, but it will take some time to come back to the previous state. Once more, I'm going to testing, okay? Terms of percentage. I forgot to reapply the deployment. That's why still it's 20. No problem. That's fine. Now the replica is 4. Now it's 5. See, it's counting here. Now it's 5 ports, okay? So now
I remember you mentioned max replica count 5, right? How come you
But
see
but
7 here?
but I didn't apply the YAML file.
Oh, okay, okay, okay.
It's cooling down. Again, I'm pushing. Okay, we'll see it's go to the maximum or not. Okay, it's going back. Okay, still going to the 7. Okay, maximum is 7 because the load test is stopping at the when the time it will create the 7th port. That's why. Yeah, fine. Now you will got the idea, right? How the Kubernetes will auto scale the pod as per the requirement. Here our requirement is CPU utilization.
One question.
Hmm.
You ran the load testing application
Sorry.
to increase the load, running something else from
Breaking. Your voice
EC2.
is breaking again.
You were actually running a load testing application from
Hmm.
the EC2, right?
This is the thing. Not easy to. I load test with a container. See, this is another pod here.
Okay.
That this pod
Okay.
will, create load to the corresponding, the above pods.
Okay.
And manually, I am create running the thing here. It's happening. Okay. I need to break with the Control C. Then it will close. The script will going down. I'll show you. Control break.
Are
Now
you
it's
passing input to that container from
right,
this
right,
tab?
right, 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 right.
Okay.
Now it's stopped, bro. Coordinate is deleted. Now you can see now this is running. Okay. There it is. You can see a error. Okay, when we're checking the top, not top or you'll get see There's no, that's deleted, already deleted when we exit from the other window. It will delete. I mean the load tester. This will cool down, okay, after sometimes we can see after 5 minutes, I think. Before it will take 5 minutes to come back to the normal state. I mean, there is one node. I mean, desired node.
Hello?
Yeah.
Yeah, if I understand, the replica where it's written 7, it can go to
The
20,
maximum.
20 maximum, right?
Yes, but for the maximum, I using a load tester, right? So the load tester, so this is my desired state. I mean, there is one pod, I think, yeah, one pod there. So I am using a load tester. This is a load tester to test the CPU utilization maximum. Okay. So I think there is something like 250% or anything like that. 250 or like our research state is 50. Okay. If the CPU utilization is above 50, then create one pod or create 20 pod, right? That's our requirement. So in our case, the utilization is above 65 or 125, right? 125, anything like that. Manually, we test the CPU. So at this time, pod is created up to the 7, okay, not going to 20. If this exceed, then it will go to 20, okay, maximum count.
Okay, that's
Yeah.
good.
Anyone have any doubt regarding HPA?
So the HPA is the feature provided by Amazon, right?
No, Kubernetes.
Oh, it's a Kubernetes. Okay.
Yeah, that's why
So
we called Kubernetes is auto scaling our container or
okay,
deploy our
okay.
container. Yeah, monitoring container,
So
all the
it
things.
okay. It will have its own way on every cloud provider then for Kubernetes. Okay.
Yeah, these all things inside the Kubernetes. Okay.
Can I ask a question? Do we have anything called vertical
Hmm.
auto scaling? Because this is
Yes.
horizontal. Oh,
Yes,
okay.
yes. But we are going with the horizontal. Okay, coming to the production environment. This is the easy way. I mean, we just spin up the pod. Okay, pod count. And vertical there, okay, vertical VPA. This is HPA. Then there is another one is vertical pod autoscaler, but we didn't use this that scaling method. I mean, that just add up the resources, okay, to the existing node. The same way, we know the vertical scaling and horizontal scaling. Then one more scaling there, that is cluster auto scaling, like that. Cluster auto scaling. 3 scalar there, scalar type. Got it.
Yeah.
See, now we are going back, right? There's the cell state, one by one, instead of 7 by 7. Now we are back to state. Got it. Anyone have doubt? Anyone?
I think Andrew, I think he asked a question about vertical auto scaling, right?
Sorry. I will check. Okay.
What about vertical auto scaling? Do we have that here too? Like in AWS?
I mean, in AWS or in Kubernetes?
Yeah, here in Kubernetes, like you show us horizontal auto scaling. What about vertical auto scaling?
You didn't know what is vertical scaling, right?
I don't know the vertical one.
Okay, I will explain the vertical one. You know the horizontal, right?
Yeah, this what you show us is okay.
Okay. Consider we have a computer, okay? Yeah. This is not in the perspective of Kubernetes, okay? Just know the term, okay? Because we use the same term in coming to cloud computing, I mean coming to virtual machine or in coming to Kubernetes, because all are infrastructure, right? If we take a virtual machine, it's a infrastructure. If we take a container, it's a infrastructure. Coming to Kubernetes, there is same infrastructure we are running, right? So I'm just explaining with a simple scenario. This is our machine, okay? So this is horizontal scaling. These are the scaling techniques. There are different types of scaling. Common is horizontal and vertical. As per the requirement, we need to choose the corresponding scaling method. Now, vertical. For these two scenario, we have one machine each, okay? Don't compare this with the, I mean, yeah. So this is a EC2 machine, consider. Here, EC2. I am going with the horizontal scaling, okay? So the scenario like uh, I am launching this machine for deploy application. So inside this machine, there's an application, okay? There's an application running inside the machine. So yeah, the traffic, okay? The traffic will spike, okay? I mean, sometimes the traffic will be huge. So this machine can't handle that much traffic. For example, there is normal traffic 100 or 200, this machine can handle. If above 1,000 or 2,000, this machine can't handle that much traffic. I mean, the CPU will be CPU utilization or memory utilization. If the CPU utilization is high, same way the memory utilization fairly high, right? So both will, I mean, hang in the machine. User can't access the pages. I mean, the web pages or like that. So for that purpose, we need to spin up the machine, right? We need to add more resources to handle the spike request, right? So we need to clone up the same machine. So using horizontal scaling, what will happen? We just clone up this machine, okay? Just to create another machine, same like this, a identical machine. EC2. And it will automatically, if we are using this scenario with the help of AWS cloud provider, the provider will do all the things. We didn't go through manually. So for example, this application here, application code here, the web server here to serving this application. So when clone up, I mean, when horizontal scaling, the machine is T2 micro, right? So consider like that. So the cloud provider will automatically create a T2 micro, then the same image. This is the Linux. So here the Linux there, and web server Apache installed in this machine. Okay, this is our machine. So when clone up, the same application is there. Okay, Apache there. Then the correct directory, the application code will be here, and this will be routing. I mean, this two machine act like as a single machine, and they will distribute the traffic. I mean, they will share the web content to the requesters. Here there is a load balancer there. Okay, so through the load balancer they will routing the thing. Got it. Coming to here, there is no downtime. That's one of the major benefit, because when comparing to vertical, I will explain the vertical also so that you can get more idea. So what are things happen in vertical? When we are going with the vertical scaling, the same scenario. Okay, so our machine have an application. So yeah, traffic high. Okay, normal traffic is below 1K, consider below 1K, and some spike time it will go to 10,000 or 20K. So this single machine can handle. So we need to scale up. We already predefine all the things. Okay, as per the requirement. I mean, if the traffic will, I mean, trigger the above like 20 or 20, 2000 or above traffic, we need to scale up. Okay, that we already provide to the cloud provider, and using the technique vertical scaling. So the target will trigger. Okay, I mean the above 2000 traffic will hit, the machine will spin up. I mean, not spin up, it will scale. Okay, so coming to vertical scaling, what will happen? This machine have 2 GB RAM. Consider, okay, 2 GB RAM,
4 GB RAM.
and the CPU processing power. CPU power is two. Consider this is 2 core. Okay, 2 core CPU. So using this resources, the machine can't handle this much traffic. I mean, the 20,000 or 30,000 traffic. So coming to vertical scaling, what will happen? We add more resources. Okay, instead of 2 GB RAM on the 2 GB core. So this will scale up to the 2 GB RAM become 4 GB RAM, and the CPU is 2 core to 4 core or 6 core. Okay, so we can provide all the things. I mean, redefine all the things as per the requirement. It will scale out. And here one of the drawback is whenever this will happen, I mean the vertical scaling happen, we need to stop this machine. Otherwise, we can't add more resources. I mean, attach more resources to the running machine. First, we need to stop the machine. Then we can add the resource to the machine. So that there will be a downtime. This is not suitable for production machine. So that's why we are using horizontal scaling for production environment. So coming to production environment, there's not downtime, just adding the machine, then adding the machine. There is a the desired state is this, and we can set up the maximum state. If the maximum state is 5 or 10, it will go to the 5 maximum. Okay. Then after the traffic will go down, the machine automatically delete and back to the normal stage. The same thing here. See, now we are in the desired state, single port. Got it?
Yes.
Okay. Any other doubts? All clear, right? I mean, regarding the HPA.
So it means HPA is the commonly used than the vertical.
Sorry.
I say HPA is commonly used.
Yes.
Yeah.
Because coming to yeah, just to take the example like Netflix or anything. Okay. So okay. So sometimes Netflix release new films, right?
Mm.
So at that time, the huge traffic there, or some other application like streaming applications, starting live, I mean live cricket or football. Just assume that, okay. So at that time, the traffic will, I mean, huge traffic hitting the target mission, right? So at that time we can handle with the multiple sources. I mean, we need to spin up, yep, to handle that much traffic. Same scenario, we can, for example, coming to Amazon or Flipkart. Okay, there is a big billion day, right?
Yeah.
Festival day, so there is huge offer. So many traffic hitting our application. So at that time we need to scale up the things. Okay. So different scenarios as per the requirement, we need to make the change. Okay.
Thank you. It's clear. So the question I want to ask, between CI/CD and Kubernetes deployment, it's like they look different. It's like they are also doing the same work, but it's a different method, or different approach, or something like that.
I mean, which approach? HBA?
Yes.
No. For example,
no, I'm not talking about the HPA with CI/CD. I'm talking about the Kubernetes itself, using Kubernetes for deployment, and then using CI/CD for deployment. There is some kind of difference I'm seeing.
This is manual deployment. We are trying here is manual deployment. Using CI/CD, we couldn't type the kubectl apply or anything like that. The CI/CD,
yes,
the mesh, I mean the automation server will, I mean the Argo CD, the automate. Yeah. So the Argo will do the thing. We didn't come here and manually apply or anything. But in manifest file, all things we need to mention. Okay.
Exactly.
Yeah.
I'm now getting, like, just knowing the difference between two of them.
Yes.
Thank you.
Yeah. Any other doubt? All of you? So coming Monday, we will I will explain one CACD, okay, the end-to-end CACD. I include maximum service in that CACD pipeline, okay. I'm
Okay.
preparing one CACD. So I am on it.
Real time, real world CSCD. The real
Yeah.
world CSCD. I want to see the real world CSCD.
Real world, we already go through the real world CACD. I mean, the DevSecOps application, we scanning, we done different scanning.
Yes.
Already we covered one real world scenario. Then coming to each scenario, okay, for example, after this, okay, I mean, you will hire from some organization, right? And in our section, there is 10 people. The 10 people will join different organizations, consider, okay. But coming to each organization, the deployment strategy is different, okay. So as per the requirement, we need to change and do the things. Got it. For example, you joined one company.
Okay.
So there is one pipeline, okay,
Yes.
existing pipeline. So someone other in this group will join another company. There is some other different pipeline. Got it. So we need to manage that pipeline. That's the scenario. Or else some new clients there. So in that case, we need to create, as per the requirement, we need to create the pipeline. So we need to integrate the required tools like Jenkins or Argo CD. So all things require, I mean, there is a requirement, okay? Just we go through the thing.
Thank you.
Got it, yeah. If any other doubt, or else we can wind up the section, right? I will share the HPA and the sample deployment. Just go through the in Kubernetes, okay. All of you, okay? Fine. Thank you. Yeah.
Thank you.
Yeah.
Thank you, sir.
Okay. Then we can wind up, right?
Yes.
Okay. Okay. Then happy weekend.
Same to you.
Yep. Okay, bye.